Hello students, this is Professor Gina, and this video is going to give examples of the law of sines and the law of cosines. We use the law of sines or cosines to solve a triangle. That means that we want to find all of the missing components. In this first example, we're given one of the angles and two of the sides, and we're trying to find the angles and side that we don't have. Just as a reminder, when you label triangles, you always use capital letters for the vertices, and you use lowercase letters for the sides. So in this example, angle A would be across from side A if you want those to correspond, and angle B, capital letter, would be across from side B, lowercase, and angle C would be across from side C. The law of sines says that each of the sides of a triangle are in proportion with their corresponding angles. So if I consider the largest angle in a triangle, that should be across, from the longest side, and the shortest side should be across from the smallest angle. Now, there are two different ways that I can write the law of sines. I can take all of these fractions and I can take the reciprocals. I just make that decision based on what particular element I'm trying to find. So we know we can use the law of sines if we have one complete fraction, as we do in this problem. We have both side A and angle A, so we can use that fraction. We also know side C, so we're going to pair these two fractions together. The component I'm trying to find is the angle C, so I'm going to write that on the top of the fraction. I'm going to start with the sine of angle C over side C equals the sine of angle A over side A. And then I'll multiply both sides by C so that I can clear that fraction over there. And I have sine C equals C times the sine of A over side A. Now, I don't know what angle C is, but I know that its sine is equal to all of these components on the right. So what I'll eventually do is take the inverse sine so that I can find the angle. I'm going to set this up so I have just one thing to enter into the calculator. So I'm going to say that angle C is equal to the sine inverse of this whole fraction here. I want to, if I can, enter everything into the calculator just once. Sine inverse, and we'll have 13. Actually, I'm going to go down because I'm not going to run out of room here. So we'll have angle C is sine inverse. Side C was 13.5. Angle A is 126.5 degrees. And then side A is 17.2. So we'll plug that into the calculator, and we get that angle C is approximately, let me make sure I've done this right, 39.1 degrees. I'm just going to double check that. Sine inverse 13.5 times sine of 126.5 over 17.2. I got 39.1. Now, whenever we think about using the inverse sine, we have to consider the fact that there are two possible angles. We got our first answer over here about 39.1 degrees, but the sine is also going to be equal to the same value in the second quadrant. So we have a second option at 180 degrees minus 39.1. So we could say that it's also possibly 140.9 degrees. Now, if we look back at the original set of information that was given to us, angle A was 126 degrees. So that 140 degrees isn't going to be possible, right? We can't have the total degrees of this triangle be over 180. So we're going to reject this one. This one's not possible because it's too large. There are times you can see in the slides that we get what's called the ambiguous case, where we actually get two different triangles as possibilities. So you always have to look at both answers that you can get whenever you're taking the inverse sign and consider whether or not there's potentially two triangles. In this case, there's not. So we found angle C. What we can do now is we can find angle B by saying that angle B is equal to 180 degrees minus A, which was 126.5, and minus C, which is 39.1. So doing that, we get 14.4 degrees. Okay. So the only thing we're missing now is side B. So we'll say B over the sine of B. We'll go back to the law of sines again, is equal to A over the sine of A. I'll multiply both sides by sine of B so that I can get side B by itself. So B is equal to A times the sine of B over the sine of A. And then in the calculator, I'll enter side A was 17.2. Angle B is 14.4. And then angle A is 126.5. So entering that into the calculator, we get that side B is approximately 5.3. When we're doing these calculations, we always want to round to the number of decimals that was given in the original problem. And since we were given things that were rounded to the 10th place, we're going to round our answers to the 10th place as well. So as our final check, we're going to write all of our answers and just make sure that they're in proportion to one another. So angle A was 126.5 degrees, B was 14.4 degrees, and C was 39.1. Side A was 17.2, side B was 5.3, and side C was 13.5. What we're double checking is that the largest angle is corresponding with the longest side, and the smallest angle is corresponding with the shortest side. And since those work out, then we know that we've solved the triangle correctly. If you get to this final step and you get a contradiction, then it's a triangle that's not possible. Okay, let's pause for a second. Okay, for our second example, we are given, in this case, we're given two angles and we're given one of the sides. So when we're given two angles, it's kind of easy to find the third angle. We're just going to subtract from 180. So, one sec. Okay, so we know that angle B is going to be 180 degrees minus 129, and I'm going to write this as, well, I'll just leave it like for a second, 32 minutes, and also minus 18 degrees 28 minutes. In the calculator, I'm going to enter this way with parentheses 129 plus 32 over 60, and then 18 plus 28 over 60. I've got pluses everywhere. Notice that I have a minus sign here, so it's going to subtract this entire sum. I've got the main degrees here, and then I've got the 2 minutes here, right? And I'm just putting them over 60. I just do this so that I don't have to use the degree, minute, second button in the calculator, which I can, but it's just a little bit easier to do this. And so for angle B, I'm gonna get 32 degrees. Since 32 and 28 add up to be 60, then we ended up with something that didn't have any minutes with it. Now that I've got angle B, I'm going to use that in conjunction with side B to find one of the other sides. So I'll use, let's say, side A over the sine of A is equal to side B over the sine of B. Or A is equal to B times the sine of A over sine B. Just rearranging that equation. So side A will be 1204 inches times the sine of 129 degrees 32 minutes, and then over the sine of 32 degrees. Again, when you enter this into the calculator, you'll enter this part as 129 plus 32 over 60. And for this, we're going to get that A is approximately 1752 inches. I'm just going to double check that. 1204 times the sine of 129. Calculator problems. Yeah, that's what I got rounded. Okay. And then the last side we need is side C. So we'll repeat again. Remember, you can't use the Pythagorean theorem in these problems because there isn't a 90-degree angle. So we've got to go back to the law of sines again. Side C over the sine of C is equal to side B over the sine of B. Or side C equals B sine of C over sine of B. So side B was 1204, right? Yeah, 1204. And angle C was 18 degrees 28 minutes. And then over the sine of angle B, which is 32 degrees. Putting that into the calculator, we get that side C is approximately 720 inches. So then we're going to put all of this together to make sure that all of our angles and sides are in proportion. Angle A was, I think, 129. Yeah, 129, 32. Angle B we said was 32, and angle C was 18 degrees 28 minutes. For side A, we got 1752. Side B was given to us at 1204, And side C we found at 720. So it looks like the largest angle is across from the longest side, and the smallest angle is across from the shortest side. So these answers make sense with the information that we were given. For this next example, notice that the lengths of side A and side B are the same, and that means that it is an isosceles triangle. When you have an isosceles triangle, that means that two of the sides are the same length. So this might be side A here, and this might be side B here. And because of the law of sines, that means that these two angles, this would be angle B, and this would be angle A, they have to be the same measurement because they're across from two sides that are the same length. But if we look at angle A being 124 degrees, that doesn't make sense, right? We couldn't have angle B and angle A being the same. So it seems like this one's going to be not possible. But let's just do a little bit more analysis with the law of sines just to verify. But it just seems like this one's not going to work. So it seems like we could use the law of sines because we've got side A and angle A. So let's put sine of B over B equaling sine A over A, or sine B is B times the sine of A over A, where B is sine inverse B, or sorry, B was 2345 times sine of 124.67 over 2345. And I think that if you enter this into the calculator, you're going to get an error message. Hang on one sec. Sine, I'm going to enter this into my calculator, 124.67 and 2345. Oh, no, we're not going to get an error message. I'm getting that sine, that B is either 55.33 degrees. That's one of the answers. Or the other angle, even though we know it's not possible, would be over here, 180 minus 55.33 is 124.67. But even if we take 124.67 plus 55.33, that's already 180 degrees. If I take this guy here and even this guy here, that's already over 180. So even if you weren't thinking about it as far as an isosceles triangle, when you get through the law of sines, you see, well, we can't have a third angle, so this isn't possible. There's a formula in the book that talks about finding the area of a triangle, and it comes from the law of sines. And it doesn't have to be a triangle that you know the height of, because you've learned in the past, area of a triangle was 1/2 base times height. The height means that we've found a 90-degree angle with the base of the triangle, right? So the base would be down here. And if we could make a 90-degree angle, then this value here would be the height. But in the case where we don't know what that height is, we can use this different formula that the area is 1/2 two of the sides multiplied by the sine of the other angle. So we can use this instead of it. It comes from or the formula that you guys learned in the past, 1/2 base times heights comes from this particular formula. So let's just plug in the numbers that we have here. We'll have 1/2, 1.5 times 2.1 times the sine of 75.16. Plug that into the calculator and get about 1.5, and our measurement was meters squared. For our last example, we'll do an application problem. In this example, we have an airplane that leaves an airport and it flies in a direction of 85 degrees. Now, we talked about bearing in the last chapter. If there are not specific directions, north, south, east, or west, that are given, we start from a northbound and open the angle in a clockwise direction. So you can see that the angle 85 degrees is here. And so the airplane starts by flying this direction. And then it has to stop at a different airport. And then when it starts flying again, it flies in 283 degrees. So again, we look at the northbound, and then we're going to go 283 degrees this way. And this is the second flight that it takes. So we're going to do this in stages to try to figure out the length, the two lengths that it flew, and add them together. So let me erase everything I've got on here. Let's label this triangle that we've drawn here. I'm going to make this larger so we can put some labels on here. Let's call this angle A, let's call this C, and let's call this B. So then this will be side B, which they told us is 230. And so we're trying to figure out the length of side A and the length of side C, and we'll end up adding those together. We know that this measurement here is 85 degrees. And do we know angle B? Well, we know that this angle here, hang on, let me draw another, because I've got parallel lines here, this angle is also 85 degrees, right? And this entire angle going all the way around is 283 degrees. So I've got 180 and then 85. So I think that this angle, angle B, is 283 minus 180 minus 85, right? Because the 180 degrees is going to be here, and then 85 is here, and so then that little piece that's left looks like that is going to be 18 degrees. So angle B is 18 degrees. Okay. And then we can subtract to find angle C. So angle C is going to be 180 minus 85 minus 18. Angle C is 77 degrees. So I've got 18 degrees here and 77 degrees there. Okay. Now that I've got those three angles, I can use the law of sines. So we know side B, so let's start by finding side A. Side A over the sine of A is side B over the sine of B. or side A is going to be B times the sine of A over the sine of B, which is 230 times the sine of 85 degrees over the sine of 18 degrees. So for side A, I'm getting approximately 742 kilometers. And then we'll repeat to find side C. Side C over the sine of C is B over sine B. C is B sine C over sine B, or 230 sine of 77 over sine of 18. So for side C, I'm getting approximately 725 kilometers. So the total distance flown is 742 plus 725, or 1,467 kilometers. All right, I'm going to take a break and then we'll look at the law of cosines. The next set of examples that I'm going to look at are the law of cosines. And the way that you know that you can use the law of cosines, or you have to use the law of cosines, is if you do not have a pair of angle and side that are corresponding. So in this example here, we're given sides A and B and angle C, but we don't have any pair of corresponding side and angle. So we have to go to the law of cosines. The law of cosines is always more complicated, so if you can use the law of sines, you prefer to do that. In this case, we'll use, there are three different versions, but they all mean the same thing. We're going to use the version that c squared equals a squared plus b squared minus 2ab times the cosine of c. We're going to start by trying to find angle C. And what we'll eventually have is we're going to take the square root of this whole thing, right? And again, if you have the option to, it's best to enter everything into the calculator once and round only once at the very end. It'll save you from rounding errors. So side C is going to be the square root of 6 squared plus 9 squared minus 2, 6 times 9 times the cosine of, I'm going to enter this as 28 plus 43 over 60. And I'll just enter this all as one long calculation in the calculator. Do that right now. Plus, and the answer that I got is 4.7. But in the example that I'm looking at, they've rounded all of the, in this example, they've rounded everything to the nearest whole number. So we're going to round this up to 5 millimeters in this case. All right. And then we'll repeat this process to find side A, or actually we have side A, we need to find one of the angles. we can switch to the law of sines now, because we've got two things that are paired up, side C and angle C. So let's try to find angle A. Let's say that the sine of A is going to be A times the sine of C over side C, or A is going to be sine inverse A sine C over C. So in the calculator, we'll enter 6 times sine of 28 degrees 43 minutes over 5. And I'm getting that angle A is approximately 35 degrees. I've got to transfer this into minutes. So you subtract off the whole degrees. I'm subtracting off 35, and then you're going to multiply by 60. Which is, I'm getting 21 minutes. I'm just going to double check that. Give me a second. Okay, I redid the calculation and I got 13 minutes. One of the things you'll find is that there are different ways to approach the problem, and sometimes you'll be off by rounding errors, which is particularly frustrating in my math lab. And for that reason, these types of problems will be the ones that I'll have you show work, so that if you end up getting an answer wrong on the exam, I can still give you credit for that particular answer. And so then the last thing we need to do is find angle B, which is the last thing that's missing. Angle B is going to be 180 degrees minus the first angle we're given was 28 degrees 43 minutes, and then we found 35 degrees 13 minutes. And so that's going to be, let's see, 43 plus 13, 4. So it'll be 4 minutes. 180 minus 28 minus, I'm getting 116 degrees 4 minutes. Let me double check that. That's 28. I'm going to pause again so I can double check this problem. Okay, so I checked that answer and is right. And just kind of putting everything back together, we have, go back up to the top, we found side C was 5 centimeters, sorry, 5 millimeters. We found angle A to be 35 degrees 13 minutes. And we found angle B to be 116 degrees 4 minutes. So the largest side is B, and that's across from the longest angle, or the largest angle. And the smallest side is C, and that's across from the smallest angle. So these look good. Let's do one more example like that. Okay. In this case, we're given side, side, side. If we are given angle, 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 we can't find a unique triangle, because the sides of the triangle could be completely different, could be a blown up version of the same exact triangle, and the angles would be the same, but the sides would not be unique. And so we can't solve a triangle if we're given side, side, side. We can solve a triangle if we are given angle, 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 like this particular example here. So let's start by using the law of cosines. We'll start the way we did in the last one. C squared is a squared plus b squared minus 2ab times the cosine of c. Oh. Sorry, I digress. Okay. So C is going to be a squared plus b squared minus 2ab cosine C, and we're going to have the square root over the whole thing. So we'll do 11.2 squared plus 5.4 squared minus, oh no, this is all wrong. Oh, Miss Gina, having a bad day today. We want to find angle C, right? So let's solve for cosine C. We're going to do C squared minus a squared minus b squared equals negative 2ab cosine C. And then we'll divide both sides by negative 2ab. So now I have that cosine of C is equal to C squared minus a squared minus b squared over negative 2ab. And then I'm going to do the inverse function. So cosine inverse of this whole thing this is going to be angle C. Let me pause and move this down. I've got too much stuff here. Okay, so I am back. We're going to now enter all of this information in. So we're going to do cosine inverse 7 squared minus 11.2 squared minus 5.4 squared over negative 2 times 11.2 times 5.4. All right, and this should give us angle C. Let me enter that. Give me a minute. And I am getting 29.18. I guess 0.19, 29.19 degrees. Okay. Then we will repeat this process for one of the different variables. Let's do b squared is equal to a squared plus c squared minus 2ac cosine b, or angle B is going to be cosine inverse. This is going to be similar to what we had before, but different variables, b squared minus a squared minus c squared. And we'll divide by negative 2ac. And this will give us angle B. So we'll do cosine inverse. B squared is 5.4 squared minus a squared is 11.2 squared minus, what do we have for C? 7. And then over negative 2, 11.2 times 7. And we're getting, let's enter this, 5.4 squared minus 11.2 squared minus 7 squared negative 2. I did something wrong because I got a domain error. So let me start again. 5.4 squared minus 11.2 squared. Hopefully you found the answer before I did. 2 times 11.2. I got 22 point, rounding it, 10 degrees. All right, and then for my last angle A is going to be 180 minus 22.10 and minus 29.19, right? Which is 128.71. So for our final check, we'll put all 3 of our angles together and all of the sides together to make sure that they're in the correct proportion. So 128.71, 22.10, and 29.19. And side A was 11.2, and side B was 5.4, and side C was 7. So the largest side is 11.2, and the largest angle is A, and the smallest side is B, and the largest or the smallest angle is B. So that checks out. All right, one final example, kind of a fun example, making me miss Disneyland. Hopefully we can go to Disneyland again soon, huh? This is a teacup ride in an amusement park, and there are 5 teacups, each equally spaced in circle formation. So the way that this is drawn, each of the teacups is going to be, at the ends of these vertices of the pentagon that we have drawn. There's an arm that's connecting them, and it's 20 feet long, and so that you can see this angle that's drawn, or the length that's drawn for the arm. So the arms are drawn here. And then if you take a pentagon, this going all the way around this 360 degrees, if you take 360 degrees and you divide it by 5, you'll get 72 degrees. So that's how they're getting that 72 degrees there in the center. The question is just how far apart are each of the cups going to be from one another? So we want to find the distance from between 2 of these vertices. And so we can use the law of cosines. We have 2 sides and the angle in between them. So let's draw another version of this triangle here so we can label it. Let's call this angle C. Let's call this side C. And we can call this side A and side B, doesn't matter. But we're trying to find side C, which is side A squared plus B squared minus 2AB times the cosine of angle C, which we said was 72 degrees. Or C is going to be the square root of A squared plus B squared minus 2AB cosine of C. So we'll have 20 squared plus 20 squared minus 2 times 20 times 20. and then the cosine of 72 degrees. Take the square root of that whole thing. And let's see what distance we get. And I'm getting about 23.5 feet. It doesn't seem like a very long distance, and that's probably why when I'm on that ride I get so scared. All right, thank you for bearing with my various pauses in this video. Having a maybe not my best technology day, but if you have questions, send me an email or send me a message through Canvas. Thanks for watching. Have a good day.